All right, in this lesson, I'll show how a identical method between a series and a data frame will operate differently on one and the other. Again, the key takeaway here is not so much to commit every single method that you run into memory. That's impossible. You'll memorize them through practice and through experience, but really to gain a better understanding of how to approach a problem and to understand that things will not always work as you might expect them to work, and you have to be prepared for thinking about what are the differences between these objects and how might these methods operate differently depending on the structure of the object. So in this lesson, I'm going to actually use another CSV for this module, and it's called revenue. So I'm going to use my read CSV method on my pandas library, open my parentheses, and it's called revenue. So I'm just going to type it out, press tab, press enter. There it is. Let's take a look. So here we have 4 columns, date, as well as 3 cities. And these are just fictional revenue numbers, so to speak, for the 3 cities on those dates. What I'm going to do is use my index call parameter. That's available in my read CSV method. And as a reminder, you can give that a string with a column name, and it will import that column as the index of the data frame, much like it did in the last module where we made it the index of our series. So I'm going to put date in here, which is our first column, and when I re-execute this, you'll see that the date column has been moved to the left to serve as the index of our data frame, and I'm satisfied with this result, so I'm going to assign it to a variable called rev and just preview the first 3 rows of rev so that we have a reference point. All right, and what I'm also going to do is actually create a series, and I'm going to call it s, give it the variable s, and use our old pd.series constructor method and open the parentheses. And usually this would be the point where we give it a variable that's storing a list, but we don't have to assign a list to a variable. We can just feed a regular old list like 1, 2, 3 into there, and it will operate the exact same way. That list will be supplied as the argument to the data parameter, and it's just going to generate a series s for us that has 3 values, 1, 2, 3. And as a reminder, we have a sum method that's available on a series, and it goes through all of the values and summarizes them, or sums them up rather. And so when we have 1 plus 2 plus 3, the result of the sum method is going to be 6, and we can see that. So what happens when we call rev on, or what happens when we call sum on rev, which is a data frame rather than a series? If I do rev.sum, the result will be kind of interesting. We're going to get a brand new series where you can see that the index labels represent the columns from the data frame, and the values of this new series represent the sum of all of the values within that column. So 5,475 is the sum of 985 plus 738 plus 14 plus all of the other values within the New York column, and the same operation holds true for the Los Angeles column and the Miami column. But what happens if we want to look at it from the other perspective? What if we want to sum the numbers horizontally? That's an operation that's not available on a series because a series doesn't have multiple columns, but a data frame does. What if we don't want to look at the sum by city, but we want to look at the sum by date? Well, as it turns out, the sum method on a data frame has an axis parameter. We can see it right here, and it's set to none. And if we set it equal to either 0, which represents the left axis or the regular index, we're going to get the same result, which is what we just saw. And if we also give it the string argument of index, it's going to give us the same result. So what it's basically doing is moving along each of the index here for every column and adding them up. So it's proceeding sequentially down the index and summing it up that way. And predictably, if we want to sum it the other way by moving across the columns left to right for every single index label, like so, we have to change this axis parameter to be either 1, which represents the numeric order of the axes, the columns axis, so to speak. The vertical axis is the second axis in line, so it's given its own index position, so to speak, of 1, while the one to the left is 0. So if I do 1, we're finally going to get a series that has the dates as my index labels and the totals of each row as the values within this series. So 1606 is the total of 985 plus 122 plus 499 summed up together. And of course, if this is confusing, the string option also works, and you can just do axis equals columns. And so it's going to move across the columns left to right and sum up the results for each index label, which in this example represents each date. So here we have the same result, a series where the index labels are the dates and the values of the series are the sum totals of each row. So, and this option, again, is not available on a series. So if I were to create an empty cell here and just do s.sum and do axis equals columns, I'm going to get an error because it doesn't have columns. And it's just going to give us this big block of scary code. So the key takeaway here is it's the same method. It has the same syntax of using the parentheses, but the way that it operates is a little bit different. It's dealing with a two-dimensional object, and so it's going to have this own default mechanism for what to summarize. And if we want to look at it from a different perspective, we're going to have to supply arguments to parameters that perhaps don't exist or don't function on the methods on another object. In this case, the sum method on a series is completely different from the sum method on a data frame. So some methods operate exactly the same like head. Some have tiny differences like this, like sum. So really, it's just an important takeaway here to watch out for those differences as you proceed. Try out methods that you know on different objects, see what happens, see if you run into an error, or see if it operates exactly the same. Look up the Pandas documentation for the attributes and parameters. See what happens when you try different values. Jupyter Notebook is really great for that kind of experimentation. But that's just an exploration of the differences, and in the next lesson we'll dive into how to start selecting single columns from our Pandas data frame.